Hello and welcome back. This video is about another very interesting topic, and it's something one very rarely hears about, and it's research findings about the connection, the very tight connection between the physical, the body, and the cognitive, the mind, so to speak. One's interest might indeed lie in virtuosity, since we happen to live in an era that sports are highly popular and well paid, as well as music and other types of performance that require exceptional skills. This is something that Sandel 2010 or Smuelhoff et al. 2012 tell us, but it's also something that we know for ourselves. However, one should not jump to the conclusion that physical performance is a different species than cognitive performance and that they could be separately studied, no matter how much this stereotype is promoted in society, mainly through the general education, mind you, which remains sterile as long as it does not recognize and exploit the tight connection of mental to motor, of mind to body. It would be very informative to cite just a few abstracts from Schwartz and Heiser 2006 chapter Spatial Representations and Imagery in Learning from the Cambridge Handbook of the Learning Sciences. So, I cite. Relevant evidence comes from studies where people accomplish imagery tasks more quickly and accurately when they are allowed to move as they engage the task. Simons and Wang, 1998, for example, showed that people more easily imagine looking at a set of objects from a new perspective when they are allowed to walk to that perspective, even if they keep their eyes closed. Wolfschanger and Wolfschläger 1988 and Wechsler and Klamm 2001 showed that people imagine object rotations more quickly when they can physically rotate an object with their hands, even if they are not directly touching the object. Schwartz and Holton at 2000 had people pull a string that turned a table on which an object rested, but did not allow them to directly touch the object. People often think of simulations as guiding possible actions. However, in these cases, actions guided imagery. The coupling of imagery to the motor system is relevant to reading. Klatsky et al. 1989, for example, told people to form their hand into an open grip or a flat palm. They were then asked, is it possible to squeeze a tomato? People were faster to say yes when they had made the open grip. So not only does embodying words through imagery and action improve comprehension, as described earlier, it also improves access to relevant possible actions and their likely consequences. The coupling of imagery with the motor system enables people to anticipate possible changes, and this can help students solve problems. For example, when rotating molecular models to see if they can bond with each other. At the same time, imagery is often limited to the complexity of action available to the body. People can only imagine so much in a single simulation. Hegarty, 1992, and again in 2000, examined people's abilities to mentally animate complex pulley systems, as shown in this figure. Hegarty found that good problem solvers simulated one interaction at a time and in the right order. For example, they imagined how the belt would rotate if they turned the crank. They would then propagate the result by imagining how the moving belt would turn the next pulley in the series. Spatial representations interact with other forms of knowledge, in this case problem decomposition, and therefore it is important to help students to develop the skills necessary to decompose a problem into a form that is amenable to imagery. The role of pre-interpretive expertise in imagery was demonstrated by Schwarz and Black 1999. Participants received the problem in this figure. A wide and narrow glass of the same heights are filled to identical levels of water. Will the two glasses start spilling water at the same angle of tilt? Very few people gave the right answer when they could only look at the glasses. In a second condition, participants were handed one glass at a time. There was no water in the glass, just a black strip indicating the pretend water level. People closed their eyes and tilted the glass until they thought the water would just start to spill out. They repeated the process with the second glass. In this case, every individual correctly tilted the narrow glass farther than the wider glass. Thus, people had pre-interpretive, action-dependent expertise that enabled them to simulate the water glass movement interactions. Again, this extensive text was from Schwarz and Heiser 2006. The authors, Schwarz and Heiser, mention many more examples, but their point is successfully presented in the aforementioned text. The authors show the tight link between cognitive and physical, as is especially stressed in their phrase, imagery is often limited to the complexity of action available to the body, which supports the proposal that traditional activities, yoga, aikido, tai chi, etc., should be implemented in general educational school programs. In the model presented in this work for expertise attainment, cognitive and physical domains are thought to be the two extremes of the same continuum, and this is the reason some of their aspects are examined separately as a result of the process of localization, but without implying that they are separate. For this reason, cognitive and physical domains are connected in the model's mechanism. It is not even necessary to argue that both the cognitive functions utilized in a mathematical problem and the physical skills that make possible the performance of a skilled athletic maneuver all stem from the central nervous system. In motor skills, it is of course necessary that physical adaptations take place, like the improvement of proprioceptive acuity, as Schmuelhoff 2012 notes. However, musculature alone without guidance from the central nervous system is merely meat. Throughout the present work, the relevance or even coincidence and identification in many cases of physical and cognitive has been explicitly mentioned. How universal is it though? The answer is that the tight connection between physical and cognitive extends to many different mechanisms and behaviors. Important cases for this relationship are included in the list of research findings presented here.